All right, moving on. Let's take a look at second problem. So this is simplified version of your actual homework. And here you are asked to write a function, and it's suggesting you to put the function at the end of your homework live script. So I'm just going to show you how this has to be done. Okay, so in this simplified problem, you are not actually asked to introduce any meaningful modification to the code, but you are simply asked to turn this script into a function M file. So I'm going to quickly show you, and then I'll also show you how you run the code as requested in part B. Okay. So first thing first, I'm going to grab the code from the script. So I have it here somewhere. So let me copy and paste here. So this is the script from the problem. So I copied and pasted here. When I run this, it generates the spiral triangles. Okay, so it's working fine. Okay, so what we now need to do is to turn this into a function. Okay, and the problem gives you the function header. It is asking you to begin with such and such. Okay, so I'm also going to grab that. And what I'm going to do is go all the way down, create a section titled functions used. And here I'm going to paste the header. Okay. And then I am going to copy and paste the script. Okay. So if you have a well-written script with clear inputs and outputs, okay, so I know that this first line has to do with the inputs, and as you can see, this M matches with that M, D angle, D rod, and D rod, rotation for degree in degrees. Okay, so I can now get rid of that input statement. Okay, and it begins with function. I like it to end with END, end. Okay, and let's indent everything for readability. Okay, indent everything. Okay, so this is all you need to do. Okay, so you take a look at function header so that you know which variables are playing the role of inputs, and you are going to get rid of the lines where those inputs were explicitly defined. Okay, so this is good. And since it is now included at the end of the live script, you can now call this function by its name with these inputs in this order. Okay, so that's what you are asked to do for part B. For part B, you are asked to run this statement. So all you need to do is grab this, paste it here, and you simply need to run them. Okay, so you are calling the function that you defined at the bottom of this document with 21, for the first one, 21 triangles, each rotated by 4.5 degrees counterclockwise. And the angle right here is the configuration of the initial triangle, the innermost triangle. Okay, so 0 means you don't rotate the initial triangle, but when you put something like 90, you are going to rotate the innermost triangle by 90 degrees. Okay, okay, so let's run this. Okay, so it's running fine, and it created 1, 2, 3, 4 plus. I'm using subplot here, and to remind you the syntax for subplot, the first two determines the canvas configuration. Okay, so you want to arrange 1, 2, 3, 4 plus in 2 by 2 grid. Okay, so you create 2 by 2 grid, and in the first one, you put this result. In the second one is here, not down there. Okay, so this is second figure, third and fourth. let me briefly talk about what this program is doing. So 21, 21, let's take a look at the first two. 21 here means that you are drawing 21 triangles. Okay, so from the innermost to the outermost, there are 21 of them. Okay, same thing here. For the first one, you are rotating each triangle by positive 4.5 degrees. So this is counterclockwise rotation. So as you can see, these lines are going counterclockwise. Whereas in the second one, you are rotating by negative 4.5. So negative 4.5 clockwise rotation. So you are seeing clockwise spiral. 0 here means that the initial triangle has not been rotated. So the initial triangle looks like this with its first vertex on the x-axis. Okay, so no rotation has been introduced in the initial triangle. Now, if here's the initial vertex, and if you follow along, the initial vertex of the outermost triangle is 90 degrees rotated. So this is positive x-axis, and the initial vertex of the outermost triangle is 90 degrees from the positive x-axis. So how do we know that that's 90 degrees? Well, if you are plotting 21 triangles, there are 20 gaps, okay? And 20 gaps of how much angle? 4.5 degrees. Okay, so 4.5 times 20 becomes 90. Okay, so in this case, it's positive 90. So from here to there, this is positive 90 degree. And in this case, it's negative 90. Okay, so from here to this vertex is negative 90 degrees. So with that in mind, let's take a look at the third one. Here, we are plotting 41 triangles, so it looks much more compact than the previous one. And since there are a total of 41 triangles, there are 40 gaps in between, and 40 times 4.5 is 120, okay? And initial triangle has not been rotated, so your initial vertex is on the positive x-axis. And if you follow along this spiral, you see that it went from positive x-axis to negative x-axis. That's exactly 180 degrees. Lastly, we are putting in 61 triangles, so it looks much more condensed. And 60 times 3 is 180 once again. So here we have the innermost triangle over here, rotated by 90 degrees. So the initial vertex is on the positive y-axis and is rotated 180 degrees. Now it is facing the left, which is negative x-axis. So 90-degree rotation from here to there. All right, so that's how you should interpret this result. And obviously for your actual homework, you have to take care of another input variable called n, and n indicates the number of vertices. Okay, so yeah, play with it, and the key modification will take place over here in this line, as well as this line right here. But other parts of the code should stay the same. Okay. Right, so that's it for this problem. So let's move on to problem number 3.